This is Chapter 5, and it deals with looping. My question is, are you getting tired of running your program every time you want to test a new value? Well, the answer is I am. So what we want to do is let the program do the work. This picture you'll see as one of the three main structures. This is the looping structure, where we ask a question, and in general it's asking, do you want to continue or not? And so the work that we've been doing is represented by this rectangle in the middle of this diagram. So we're going to use something called a while statement, and in Python we'll have the keyword while followed by a condition, followed by a colon, followed by a block of statements, and I indicate that it's an indented block. The condition that we're testing is Boolean, so we're going to have a true or false result from that. In order to do this, we'll use a loop control variable. So the while loop lets us execute the statements as long as a condition remains true. Now what we'll see is actually it could be true or false depending on how we write the while statement. To make the while loop end correctly, we use a loop control variables that will determine how many times we repeat that body of code. In order to do that, we've got three actions that must occur. One is that the loop control variable has to be initialized before we enter the loop. Two, the control variable value will be tested. And if the result is true or false, the loop body is entered. And three, the loop control variable is altered in the loop body. And that way the condition that we're trying to check will eventually become false or true, so that the loop that we're in is executed. We have different kinds of loops. One is a definite loop or a counted loop. That means it executes for a definite number of times. So what I want you to look at is figure 5.3, in which the while expression compares a count to 4. So we'll look at that in just a moment and see that we're going through for exactly 4 times. So my question is, do all three of those necessary conditions or those necessary actions occur? So here's our diagram, and we'll see that there are some declarations, there is a decision, and so on. And what we're interested in this loop is, do we have the first condition met? Well, one, the count is initialized. So we'll notice in this block that count is determined to be a number, and it's set equal to 0. So it is initialized. The second action that has to occur is that count is tested. And so we ask, is count less than 4? If the answer is yes, we take one branch, and if the answer is no, we take another branch. So what you'll see here is that we've got a true or false answer. And the third is that in this loop, somewhere before we make the decision again, we're going to alter count so that the loop does eventually terminate. So this is our counted loop or our definite loop. We're going through it 4 times. We can also have an indefinite loop, and that will use something called a sentinel value. And in this case, the user will be asked to determine when to stop looping. Here's the example that we are inside this loop, that we ask the question, should continue equal y? So we're asking, do we want to continue? This may not be the prettiest decision that I've ever seen, but should continue is equal to yes. So if the answer is yes, we'll take the branch that goes to output hello and so on, and eventually it comes back to the top. So 3 conditions again. Let's double check. We've got input should continue right before the loop, so that means that it is initialized. We are checking its value. That's the second action that has to be there. And then the third action that must be there is that we're somehow manipulating it so that the condition is ultimately such that we get out of that loop. And this is left up to the user, and that's our no condition, which takes us down here to output goodbye. So if we enter anything besides Y for yes, then we'll take the branch that goes to the output goodbye and ultimately to stop. We can nest loops. That means that inside a loop I can have another loop, and when we have one loop appearing inside another, the loop that contains the other is called the outer loop. This is pretty clear when we look at the code, and the other one is called the inner loop. So I want you to follow the example that is given to you on pages 186 to 191. Again, a very straightforward example, but you need to go through each of the pages, each step. There are looping mistakes that are commonly made, and most of those have to do with those three actions that we require to occur. Failing to initialize the loop control variable, failing to alter the loop control variable, using the wrong type of comparison in the test. Another thing that often happens is that programmers will put statements inside the loop that really belong outside the loop. Another type of loop, we've just looked at the while loop, is a for loop. And we've already seen some simple for loops early in this class, but it's another definite loop. It goes through for a certain number of times. We can use the range function to specify how many times we want to repeat the body of code, or we can also do it for certain values. So we've already seen that for is used to move through a list, and we can also nest for statements. Here's an example for x in range 1 to 10, and then we can say inside that, or the inner loop, we'll say for y in range 1 to 10, and we'll print x and y, and then the product of the two. Something I'd like for you to try, write a Python program that returns the name of the week given a number 0 through 6 for Sunday through Saturday, and reply none for anything else as long as the user wants. You've already done this once, you've written this program, and so now what I noticed, I got tired of having to rerun the program so that I could try another value and check to see if my program was working well. Thank you.